Hello everyone. We learned about predicate and quantifiers. In this segment we are going to see some translation and negation of quantifier. We know that a predicate logic becomes a statement using a quantifier. When we have a statement with the predicate logic and quantifier, alright, we are going to see actually how we can translate a statement, or given a translation, how the statement looks like, and we are going to see actually how the negation of the statement will look like. So um, now the translation means actually like you have a statement with the predicate and and the quantifier. Now how actually we can translate them using like English sentence? So that's actually mostly like straightforward. We are going to we know that how a existential quantifier or universal quantifier is read like. Okay, so for example, here we have a statement px, and it's represent a statement like x has taken a course in the programming. Okay, and let's say we know that here we are going to have a domain is list of students in my class. Okay, what does that mean? Now how I can read that? So this will be read as like, for every students in my class, okay, has taken programming course. So it will be read as like, every student in my class has taken programming. Okay, so it's like that. We are reading it like that. For all x, this is true that x has taken programming course. Okay, or just more naturally we can say that every students in my class has taken programming course. Okay, so and this one I can say that there exists one student, at least one student, who has taken programming course. Or I can actually more naturally I can say that some student, okay, some students in my class, okay, have taken programming. All right, now what happens if we negate the quantifier statement? Okay, so let's see, px, we are using the same example. Px be the statement x has taken a course in the programming, and the domain is list of students in my class. So this one is read as like that, every students in my class has taken programming. Okay, so if I now use a negation of like that, what it will be read? So we are saying that this one represent every students in my class has taken programming course. But if we use the negation, that means that more naturally it means that not every student in my class has taken programming course. Maybe some of them, but not every students in my class has taken programming course. So we are saying that there could be some students, there are some student who hasn't taken the programming course. Okay, so there are some student, so this will be read as, okay, there exist some students who hasn't taken programming. Now when I translated this is like that, what do you see? I'm using something like that, there exist, okay, some students who hasn't taken programming course. So who hasn't taken programming course, what does this mean again? So if px represent that x has taken programming course, okay, and x, now what will be like not px? Not px means x hasn't taken programming course, okay, so it seems like it is a not px. All right, and there exist some students, that means it seems like existential quantifier. Okay, so the negation of this one, I am saying that not every student in my class has taken programming course. Okay, it can be read as same like that, there exists some student who hasn't taken programming course. Now I can represent that also using a existential quantifier, which will look like that there exists some student who hasn't taken programming course. Okay, so the negation of universal quantifier, okay, is same as the existential quantifier of not of the propositional function. Okay, all right, now let's see the negation of existential quantifier. Okay, so negation of existential quantifier, so this statement without the negation, that represent some of my students some of my students has taken programming course. Okay, there exists at least one student who has taken programming course. So what about the negation of this one? So that will be read as, we are saying that by this we are saying that there are some student who has taken programming course. So if we use the negation of that, that means there are no students who has taken programming. All right, so what does that mean? So now if I say for all students, for every student, for all students, this is true that they haven't taken programming. So for all student means I am using universal quantifier, they haven't taken programming course, it means that negation of my predicate logic. Okay, px stands for x has taken programming, and not of px stands for x hasn't taken programming. Okay, so that means this is same as writing for all x not px. Okay, for all x this is true that none of has taken programming course. Okay, I mean for all x this is true that they haven't taken the programming course. Okay, means there are no students who has taken programming course. So this is actually our De Morgan law. All right, so if we negate a universal quantifier, that will become a existential quantifier with a not px, and if we negate a existential quantifier, that will become a universal quantifier with not x. All right, so this statement will be true, all right, when px is false for every x. Okay, this statement will be true for when px is become for every x. So obviously, so if we have this one, that means this will become so this will become false. Okay, this will become false if every px is false. Okay, every px is false for every x. All right, now if I use the not, that means this will become true when px is false for every x. All right, okay, now what about this one? So for this one we can say that there exists p of x, right? So if for every value, I mean for this one, if we find, okay, at least one true, that means this is true. Okay, now if every one of them is false, okay, the whole thing will become true. Okay, so again this will be false when there exists an x for which px is true. Okay, so this means actually like this one. Okay, but this will becomes false when there exists an x for which px is true. So like this one, for this one, for existential quantifier, the negation of existential quantifier will become true when there exists an x for which px is false. Okay, and it will become false when px is true for every x. So we are having some class practice here. I'm going to solve the first one, then I'm going to actually leave the rest of them. Okay, and I will actually suggest you to practice them by yourself. Okay, then I'm going to actually post the solution later. All right, but in this segment I'm going to practice only the first two, and I'm going to leave the rest of them for you to practice. So this one says that we have a domain list of all politicians, and predicate is p of x represent that x is honest. Okay, so we are going to translate the following statement using quantifier. All right, okay, so we have a list of politicians, and x is, we are saying that px means x is honest. So the first one is saying that there is an honest politician. Okay, so it means that in the list of politicians there must be one politician which is honest. Okay, one politician which is honest. So that means we are going to translate them using existential quantifier, where there exists one politician for which p of x is true. Okay, all right. So how about the second one? Every politician is dishonest. So if px is x is honest, the negation of px means x is dishonest or x is not honest. Okay, all right. Now how I can translate that? I can say that for every politician this is true that x is dishonest. So one way to do that, I can use the universal quantifier, and I can say that for all x p of x is false, means for all x not of px. Okay, so this one represent x is dishonest, and I am saying that every politician means for all x is dishonest is true, means every politician is dishonest. Okay, so we know that it is same as writing, I'm sorry, so these two statements are logically equivalent. I can write it also like that, and it means that there doesn't exist one politician who is honest. Okay, so it will be read as like that: there doesn't exist one politician, one single politician, okay, who is honest. All right, so they means actually they both mean same, but it will be read just with a different tone. That's it. Okay, so this the second one can be translated using either this way or this way. All right, so in this example we have a domain all Americans, and the predicate means it represents x eat cheeseburger. Okay, p of x stands for p of x such that x eats cheeseburger. So now let's translate these following statements using quantifier. So we're saying that all Americans eat cheeseburger. Okay, so we can translate them using universal quantifier. We can write that as like that: for all x px is true, means for every American they eat cheeseburger. Okay, now what about the second one? Not every American eat cheeseburger. Okay, so we say that every American eat cheeseburger, but it is saying that not every American eat cheeseburger. So seems like it will be like that, not. Okay, so it will be read like that, not every American eat cheeseburger, or I can see that, read it like, write it like that, or also I can write it actually just like that. Okay, so that means there exists one American who doesn't eat cheeseburger. Okay, so if px means x eats cheeseburger, now not of px means x doesn't eat cheeseburger. Okay, so here it's saying that there exists one American, at least one American who doesn't eat cheeseburger. Okay, all right, so there are some other exercise for you. I'm going to leave them for you to practice. Please do that. I'm going to actually post them by tonight. All right, means I'm going to post the solution by tonight. Okay, but you have to actually try that before then.